Hey everybody, we're here in the Corley building, home of the Biosystems Engineering Department on the campus of Auburn University. They, along with the Crop, Soil, and Environmental Science Department, are doing research on drone technology use in production agriculture. So come along with us as we learn more about how they take drone technology to the farm and how they're preparing students to use that technology in the field. So tell us about yourselves and your research.
Hi, my name is Yin Bao. I'm an assistant professor in biosystems engineering. I work in precision agriculture and forestry for the past 4 years. I develop technology to help save labor and also improve the production efficiency in agriculture and forestry.
My name is Tanzil Rahman. I'm an assistant professor in biosystems engineering, but I also have a joint appointment with horticulture. So most of my research work is pretty much on precision horticulture. So it's developing technologies for specialty crop production, ornamentals, fruits and vegetable production to improve the production, save the resources, minimize the inputs and stuff like that.
Cool. So, so obviously you're doing like precision agriculture. So tell us why you feel like it's important, why it's an area that you do research in, and maybe how you're using that technology to improve production.
Yeah, the biggest challenge today is to produce enough food, fuel, fiber for the global growing population. So precision agriculture provides means to improve efficiency and efficacy, but also reduce the environmental impact during the production process. So it's very important that we develop the technology to make sure that we can feed the global population in many years ahead.
I think from my perspective, precision horticulture, the biggest thing is again sustainability, to make sure that we have sufficient produce or specialty crops so that we can fulfill the needs of the future generations. But also looking at in a sustainable fashion how we can reduce the resources. Let's say if we have labor challenges, how we can avoid those issues or the bottlenecks that can increase our productivity, how we can have minimum inputs, and also how we can take into account the climate or the changing climate. All those things I think are helpful to develop the technologies, or are really required, the technologies that can take into production for the future generations.
Here we are with the field research team. So you guys get to go out and test everything and make sure it works. So how do you all work as a team to get this stuff out here and get it tested?
So basically what happens is a grant will be written for a large project, right? And it'll get funded, and so the professors will come talk to us like, hey, we want to work on X, Y, and Z. For instance, this robotic, what some people call the robotic tractor. We have several names for it, but this unit here was a project that we're using inventorying pine seedling nurseries, which is a very manual labor task right now. They're basically, all the pine seedlings are counted by hand. So they're looking at a way to do this autonomously and more accurately. So we help come up with, hey, how are we going to do this? So we bought this unit, we built some of this prototype stuff you see on the front here, and we kind of put that together and we collect data. And we give that data back to professors, and we work back and forth with them and kind of continue this project on so it'll be a long-going project, because we'll be doing a lot of collecting data, proofing that out, and seeing how accurate we get over time. And we have at any given time 8 to 10 of these type projects going on. So we work a lot with in precision agriculture and precision forestry and the applications of technologies in those industries.
Okay. So tell us a little bit more about this specific robot.
This actually is the second, probably the third iteration of this system. It seemed that there was a need in industry for this type of technology, and so we reached out. Actually, James reached out to one of the nurseries and we got contacts, and Dr. Bao had a grant, and then the first one actually was an implement that went on the back of a tractor. We hooked it up and we actually took the tractor to the field and ran it, and it would hook to the 3-point hitch. And then that kind of evolved as we figured out what worked, what didn't work, what got stuck on the seedlings and so forth, and then we've come to this point now. And that usually is the case with most of our projects. We start with a prototype, we go give it to them to test it, and then we figure out what worked, what didn't work, and we use engineering principles to try and improve that technology, make something that's usable for the client and the customer and the grant application.
Yeah.
Another unique thing about it, like basically everything involved here, and we're missing some of the pieces for being able to transport here today, but everything out here was kind of what we worked on and came up with. And this is just a typical, like a 3-point hitch unit that will be on the back of a little tractor. So this is something, minus some few changes we made to this, you can almost purchase this now, a unit very similar. So that's another thing that we do a lot of, is how can we take things that are existing that we can buy relatively cheap to not reinvent the wheel, but tweak those and make them do a whole nother job.
Yeah.
If that makes sense. Because if you have to build this entire thing from scratch, you have put so much work into just figuring out all these little pieces. Or if you can buy this unit cheaper than you could ever build it and outfit your technologies on it, then you're a step ahead of the game there. So it drives just a typical, like a skid steer type operation. Mm-hmm. So these wheels are all, they're just locked in. So what that allows us to do is have a very, once you get it on a line, you have a very easy, straightforward path. It'll stay straight, no problem. And so you're kind of sitting in 2 furrows and the beds will be in the middle. And there's adjustments on these wheels. So we can basically, depending on what we want to look at, if we want to look at, like, let's say we want to lettuce. And let's say we can narrow these wheels up and just run over one single row, or we can set it up to run multiple rows. So these easily just slide right in and out. But it's set up to run just like a skid, and it's bi-directional. You know, you can run it this way if you want the implement on the front, which way we have it set up now, or it's easy to run it this way, right back toward you, just like that, forwards and backwards. And when you get to the end, it's simply just almost like a skid steer operation. You just turn one side or turn both sides, and it just turns right around there. And then once it gets set up on the next line, and GPS knows where it's at and it lines up, it's ready to go right down and start back doing your inventory, or running NIR cameras, doing collecting samples for NDVIs and stuff like that.
So Trent and Caroline, tell us about this drone. What does it do?
So this is a SenseFly EBX. This is what we call a fixed wing drone, as opposed to a quadcopter type drone or any kind of propulsion type drone, kind of like I think of them like helicopters and airplanes, kind of. So this one we generally use for general land survey, whether that be elevation maps, just general aerial images you can use to survey a site, or like a forestry harvest site that's might be hard to reach. The drones kind of make that easier. And we also use it for NDVI imagery for monitoring crop health.
Okay.
So we've done that in the past before as well.
We can also make orthomosaics with this drone. So it doesn't take videos like some of the quadcopters do. It just takes a bunch of pictures, single pictures, and each picture has the pitch on roll the plane as it's going around. And so when you're flying, each picture knows exactly where it is. And so an orthomosaic map is when you put all the pictures together and make one big map, and then you have an accuracy of, this one can get up to sub-centimeter, about 5 centimeters is probably the realistic accuracy, which is really great. It also has an interesting way of landing, and y'all will see this, how we take off and land, unlike the rotary wing drones. It lands on its stomach and you'd have to throw it to take off, which is a little different. It also can tell you, you'll see on the control panel, we'll show you, you can see how fast it's flying, the wind speed, the temperature of the cameras we have in here. We have a couple cameras that we can fly with it. It can also fly for about an hour, whereas most of the rotary wing drones have a shorter flight time. It doesn't have as high of a weight capacity as most of the rotary wing drones, but you can collect a lot more data a lot quicker.
Yeah.
Probably about 150 acres in about an hour,
Yeah.
which is pretty incredible, and especially if you're trying to get data quick and process it.
Right.
So this one is also autonomous, so there is no remote option at all. It's completely flown with a computer. You preset the flights and the home point and the landing point. You preset the altitude and everything like that, and then you launch it and it does its thing, and then it comes back and lands. It will also give you an alert if you're going to land in a tailwind. You can change the landing angle and direction before you fly, and you'll probably be able to see some of that today. Trent can show you a little bit of that on the controls.
Cool. So when you would launch it, you'd come back and look at this stuff, or just your controls that you're going to show us?
So you have to have two people to fly. So Trent will be doing the controls today, and I'll launch it. So basically, I'll be watching the drone, and then Trent will be watching the controls. And so you'll be able to see as the flight path goes around, as the drone's taking pictures, it'll make noises. You can hear it taking the pictures, and you can see where it is on the map, as well as having a visual observer out in the field too.
When I went through school, they didn't even have the drone program, right? And then when Caroline went through, we were just kind of starting it. But now that we have the Batman program that Trent went through, that's part of some of the classwork they do. So we actually have labs where we'll take students to E.V. Smith, and we'll take them out and we'll kind of show them how we set up flights, how we even work on these, maintain them, keep them up, how we collect data, and then we'll bring that data back and we'll teach them kind of how they process it. They have labs set up for that. So it's part of their program now. Now, to get an actual license is not, but that's a program you can do through Auburn at the airport. But as far as how to use them, we teach that in the classes.
We actually do a lot of demos out here. We teach a lot of labs, like James was saying, kind of explaining to biosystem students, but also BATM students, the uses, the benefits, the pros and cons, a lot of the troubleshooting issues that we've seen along the way with the different drones that we've had. This is the second. We had an EV Plus before this, and some of the issues that we ran into with that, troubleshooting it, and there's nothing like thinking on your feet when you're in the field and the drone tells you it's negative in the ground level, and you've got 30 kids out here waiting for it to fly. That'll teach you some quick thinking. So, but Trent was in on most of that. He got the front stage view here of learning all this and seeing all of it.
So it seems like precision ag, the technology is going to touch every aspect of agriculture in the future. So how important do you think it is for students to know the technology and to, be able to talk about it with producers and encourage them to use it?
Yeah, I think it's critical for our current generation to learn about these technologies and become the next workforce for future agriculture. So right now we don't have a lot of curriculum in artificial intelligence, but it's definitely becoming more and more important because it's touching every industry and is revolutionizing each and every industry. So I think we need to be more aware of AI and the techniques and also the implications, and also we need to be trained on how to use these technologies to solve our problem in our own domains. For example, it could be livestock production or plant production.
I think it's not only the traditional agriculture anymore. It's more with all these new cool tools and technologies. Data is pretty much everything. Every machine, whether it's a tillage equipment or it's any basically equipment, you are collecting data, and the data is the key. It's important. So how we can utilize that data to make more informed decisions. So I think it's very critical for our younger generations to deep dive into some of the technologies that have been developed or that are in the process, to understand what's the background and how they can leverage that data or the amount of information coming out of those daily processes, which are which are being currently carried out, and use that information for making more informed decisions to reduce the inputs, to increase the sustainability.
So Trent, talk to us about your Batman degree. What did that look like? Why did you choose to get that degree?
I think the hands-on aspect of it is really what pulled me towards it. And it's new stuff. I mean, like we've showed y'all our drones and all this new equipment, and it's taking all of that new equipment, stuff that most people are not necessarily familiar with because it's kind of just becoming a big popular thing, and using it in a practical application. So that's kind of, I mean, that I feel like I'm decent at that, and that's kind of how my mind works. So that's really why I ended up going that way.
Do you feel like it's setting you apart for industry? So when you go out into the industry, now you have this technology piece that maybe some other students aren't getting?
Yes, I would say the way that the agriculture industry is going at the moment, precision agriculture and agriculture technology, that is the big thing. I've kind of learned that through work during school and internships over the summers. It is very big, and it's happening very quickly because all these things, they come out, and 2 years from now something new will come out, and then something new will come out after that, and so we try to stay on top of it and keep the ball rolling.
So advice for students who are in college now, now that you've been out for just a little bit, what things should they be doing to help prepare them for the new technologies?
Get as much hands-on experience as you possibly can because everything changes so fast. You want to be able to use, I won't say use anything and everything, but you want to be able to use as much as you possibly can because softwares are different between different companies and equipment works differently between different companies, that kind of thing. I would say get as much experience as you possibly can, and that way you're better, whatever situation you may end up in, you're better prepared for it.
Hey everybody, we're here at Dixon Farms with Garrett Dixon. So Garrett, tell us a little bit about who you are and what you do here on your farm.
Well, I'm the sixth generation to farm here in Lee County. I grew up on my granddad's cotton and peanut farm, and once I graduated from Auburn, I knew that I wanted to farm in some capacity, and I was able to come back to the farm and bring land back into production and start farming with my own operation.
So you're utilizing precision agriculture. That's why we're here today.
Right.
So tell us about how you're utilizing it and maybe why you think it's so beneficial in helping you as a farmer.
So we use a lot of different technologies on our farm. Our two main crops are cotton and peanuts, and basically every application we do, whether it's spring tillage to planting, spraying, and fertilizer applications, even when we get into harvest, everything utilizes some form of technology.
So I guess, yeah, how have you seen it? I mean, obviously, have you been using precision agriculture long on the farm, or has it always been here?
So when I started farming, I began to ease my way into precision ag. I knew it was important, and I knew it would provide cost savings as well as reducing the amount of inputs that we have to use. So not only does that save us money, but it keeps us from wasting fertilizer and things like that. So it helps us to be more sustainable and things like that. But when I was on the smaller scale, I kind of had to slowly bring in that precision technology just because of the cost of the systems and things like that. And so over time, as our acreage has increased, we've also increased our precision ag technologies. Part of that is probably twofold. One, with the more acres, it was easier to justify these expenses, but two, as we're able to utilize these systems more and more, it's a lot more feasible to bring them in because we see the benefit of them sooner.
What tips do you have for students who are looking to enter the agricultural industry, particularly with the precision agriculture? What knowledge should they be gaining now while they're in college, and how do they get ready?
The best way to learn is by experiencing. So I would encourage internship opportunities, or even if it's as simple as working for a farmer one summer or something like that. Even if you are looking to go into production ag, I would encourage you to at least spend some time working for someone else, because there'll be other things that you can pick up from them. But Dr. Steve Lee is a great resource. He does a lot with precision ag technologies, and even go into some of the research farms. You know, they have all kinds of technology there, and if you don't have a farm that you can go get those experiences with, you can at least go there and kind of get a crash course in those things, because even if you go work for a retailer or something like that, they utilize these technologies too. So just finding ways to get exposure to them while you're at Auburn would be a great start.
So we're here with Dr. Steve Lee. He's going to show us all things drones right now on the Dixon farm. And so Dr. Lee, introduce yourself. Tell us a little bit about who you are and how you work in the college.
Yeah, sure. Good morning. My name is Steve Lee. I'm the Extension Specialist and Associate Professor of Department of Crop, Soil, and Environmental Science in College of Agriculture.
So you work a lot with drones. So how do you work with producers, stakeholders on using drones?
So it's a very new technology. I first started to work on drones about 3 years ago. For spray drones, it's only for about 2 years, but the technology evolved very fast. So we evaluated spray drone mainly for row crops. We tested a lot of different applications, and also at the same time, we find a lot of very unique usage in specialty crop, horticultural crop, for example, container nurseries. And also we will test the spray drone in blueberry and citrus as well. So it's a very versatile tool. You can do a lot of things with it. Most of the traditional pesticides, chemicals, fertilizers can be applied by the drone aerially without touching the ground. So this provides us with unique strengths. For example, when it rains too much, we can still apply chemicals timely to control the pest without even having to worry about field being too soggy. You may get stuck in the field, that kind of issue.
So why is drone usage a game changer in agriculture?
So it's very new technology, and also it has its own unique fit because first of all, we can apply chemicals very timely, and also we have the ability to use mapping drone and the multispectral drone to generate very precise prescriptions. So this type of new technology will be able to spray the field very precisely. For example, precision spot spraying is one of the projects. I team up with Garrett Dixon, and he allow us to spray the patches of weeds here. So instead of spraying the whole field, say 35-acre field, we typically only hit about 1/3 of the total field, and we can cover about 80 to 90% of the weeds, which translate into 60 or even over 60% of chemical saving. Hopefully that will generate more encouraging results in future trials. And also, many growers like the spray drone because the cost is a lot lower compared to the traditional ground sprayer. Full package of the largest spray drone is about only 1/10 of the cost of a big sprayer. Efficiency-wise, the spray drones have picked up significantly over the last few years. 7-8 years ago, when the first spray drone was commercialized, it could only spray 3 to 5 acres per hour. Now we can spray 30 to 50 acres per hour, with much more efficient setting and a more capable drone with bigger tanks.
So a farmer or producer decides they want drones flown and to help them with their fields and things like that. So they go and they get certified, just get take a test on how to operate a drone. How's all that work?
Oh yes, it takes a formal process which can get a little long to obtain all the license you need. First of all, you need to apply for the drone registration number because these spray drones are mostly heavier than 55 pounds. So you will need to apply for a N number, which is the same as aircraft registration number. And then you need to file a few exemptions with FAA, the biggest one being the FAA 44807, which is the heavy drone exemption. That allows you to fly this type of drones legally on top of or over the 55-pound limit. And then many drone operators already have the Part 107, which is the remote pilot license that allow you to fly drones. If you do not have one, you'll be able to take that exam on Auburn campus and also at many other locations. This is a fairly well-known exam that most people need to have. The last one, which takes most of the time for people, is called Part 137. So this license technically allows people to do crop dusting aerially. So this is generally what we call crop duster license. So if you want to spray chemicals, spread fertilizer, spread cover crop seeds, basically do anything other than spraying water, you will need a Part 137 license. So this is a general overview of the certificates and the license you need from FAA. At the same time, you need to have valid pesticide applicator license from the State Department of Ag. So it depends on you spray your own farm or you spray for other people, you will need to have either private license or a commercial area applicator license.
Okay. So you work with a lot of students, you hire a lot of students to help you with your research. What are you seeing, what things should students be doing now while they're in school to prepare them for all these new technologies?
I would encourage our students to reach out to faculty working on the new technologies because we're always looking for student workers. We're always looking for young, ambitious people to work for us. I say that's the best way to learn about the new technology. So, for example, a junior or senior can come to my office and just hang out for a little bit. We can chat about the new technology, and also they're welcome to participate in some of our field work and field projects so they can get some hands-on experience by mapping a field, by learning how to use remote controller and also how to set up the drone, how to refill chemical, and just learn this whole process. We're happy to offer that kind of opportunities. And also we host extension trainings, field days, and lots of workshops throughout the state. All of our students are encouraged to attend those public events just to learn more about this latest updates of the new technology.
Yeah. So what opportunities career-wise are available for students? They're maybe not going to go back and be a producer, but how can they play a part in all these technologies? What careers are available to them?
So for this type of new technologies, I know there are lots of interest from the industry in general. So whether these students want to start their own business, which is really thriving these days, because I can name a lot of operators from other states who have started their own spraying business, and many people hit home run in their first year of operation. Because the need from the production. So establishing their own business is definitely one viable option for all of them. And also they are able to utilize the experience in precision agriculture, in drones, in remote sensing, to be able to leverage more advanced jobs or leverage better job offers, because many of the employers will consider this type of knowledge as a big plus. So you will basically have something unique on your resume that you can promote yourself better in front of recruiters to stand out from the pack. That's another advantage for students to get involved in this type of new initiative and learn new technology, in my opinion.